In this video, we're going to talk about AsyncTask. AsyncTask is a class provided to us by Android that puts a nice wrapper around traditional Java threading. Especially, it makes it easy for us to call a separate thread, put logic in a separate thread, and then when that separate thread is finished, we can update the user interface based on the results of that thread. Traditionally, that's challenging to do because we have to communicate from one thread to another without locking it. But an async task makes that pretty straightforward. The only trick is, to understand an async task, we need to know a little bit about generics, which we've already discussed. We need to know a little bit about traditional threading in Java, which we've already discussed. And we need to know a little bit about inner classes, which we will discuss. So to create an async task, we have to create a class that extends async task. But typically, for that class to be useful, it has to have access to attributes that are defined on the user interface thread. Therefore, the class that we make has to be an inner class, or a class within another class. That's a little bit tricky. We'll take a look at that in just a moment. First, let's look at some of the important methods of AsyncTask. We're looking here at the documentation for AsyncTask on the Android developer website. Some of the important methods we're going to have. Number one is the method doInBackground. And note that this is declared abstract. What an abstract method means is that this class must be extended by a subclass. And when it is extended, that subclass has to override this method doInBackground. That's the definition of an abstract class. Okay. Now we see some interesting things here. Look at the return type. The return type is result. That's not actually a class or a type or anything. It's something that we will define by using generic identifiers. Also, look at the implicit parameter. The implicit parameter is called params. Again, that's not an actual type. That's something that we will define when we override this class. But anyway, I digress. The doInBackground method that we see here is very similar to the run method that we saw in the, let's see, I need to pull it back up here. It's very similar to the run method that we saw in our plant places video in our last video, where the run method is the stuff that runs in a separate thread. The run method is the stuff that runs in a separate thread. That is what our doInBackground method is here. This is the stuff that will run in a separate thread. Whatever we want to run in a separate thread, we have to put in doInBackground. Okay, every other method will run on the UI thread, except for doInBackground. doInBackground is the only method that will not run on the UI thread. onPostExecute invokes invokes before we invoke the doInBackground thread. I typically don't use that a whole lot. onPostExecute is very important. This method is going to be called once the doInBackground thread has finished. And onPostExecute will run on the UI thread, so it has the ability to update UI elements and widgets. Only things that run on the UI thread can actually update UI elements. So doInBackground cannot directly update UI elements because it runs in a separate thread. onPostExecute can update UI elements because it does run on the UI thread. Look at that, runs on the UI thread. Okay, runs on the UI thread. Okay, so notice something interesting here though. The result here that's returned from our thread gets passed in to onPostExecute. So doInBackground is going to do a lot of work, and when it's finished, it's going to return a result. When it's finished, onPostExecute will be invoked, and it's going to receive the result that was returned from doInBackground. So how do we use this? doInBackground might do a network call that gives it some results back. And that network call has to happen on a separate thread, so it occurs in doInBackground. When it's finished, onPostExecute will execute, and it will receive those results, and it can place those results in a list activity or something of that nature. A couple others, on progress update, that will allow us to do a progress bar or an hourglass or something like that that shows a percentage complete. And then on canceled or on canceled result, this will happen if the user chooses to cancel an activity. So that's one big advantage of threading. When we thread, when we take things off the UI thread, the UI can remain responsive to the user, which will give the user an option to cancel a process that has gone on too long. If you've ever used an application and you accidentally hit the submit button or something like that, and it causes the application to lock up, or it causes you to wait for a while and you want to cancel out of it, that's where this is really good. That's where it's handy to allow the UI to run in a separate thread so you can give the user an option to say, you know what, this is taking too long, or maybe I pressed the wrong button, so I'm going to cancel that. Okay, so these are important methods that we will override if we want. Another method that we don't need to override, but we will invoke, is the execute method. The execute method will allocate a new thread, and then it will invoke this doInBackground method in that new thread. So the execute method has already been created for us. We just have to invoke it. Actually, it's this one down here. We just have to invoke it. Okay, the execute method has already been created for us. We just have to invoke it. It will allocate a new thread, and then it is going to invoke doInBackground in that new thread. That thread will run until doInBackground completes, and then doInBackground returns its results to onPostExecute. So that's a lot of talking. That's a lot of talking. Let's see if we can figure this thing out with an example. If I go to our plant results activity, right now we just have this onCreate happening, and then we dummy up some results. If the user entered redbud, we return redbud. If the user entered pawpaw, we return pawpaw. If we don't have any results, we tell the user we don't have any results. And we know eventually we're going to want to wire this up to the live JSON page here on plantplaces.com. But to get there, we're going to have to issue a network call, and in Android 4.0 and greater, we have to do that network call on a separate thread. It's a good idea in any version of Android, but we have to do it in Android 4.0 and greater. So let's refactor our existing program into a separate thread. Okay, I'm going to do a little bit of magic here to get this to fit on the screen better. I'm going to Control M so we can focus on our class. I'll leave the line numbers, and let's see if we can resize it just like so. Okay, first of all, what is a class and what is an inner class? A class is this line that starts with public class and then has an open curly. If I click right next to that open curly, it will highlight the contents of this class. Now, an inner class is a class within a class. Okay, so an inner class is something that has to happen within this blue highlighted area. We can add more room, that's fine. I can go to this on list item click, I can add a bunch of spaces down here. Let's make sure that this is a safe place to put our inner class. Okay, here we go. Anything in the blue area is within the scope of our class. So that's a safe place to put our inner class. Now, what we want to do is we want to say class. Okay, we start with the word class, and then we name the class something that we want. We could call it plant search task extends async task. Okay, and there's our inner class. Now, the trick is we have those generic identifiers. Remember, part of the reason for having generic identifiers is that we can have methods that accept parameters and return results. But we can leave the parameter type and the return type undefined until the method is overridden. And that's what we're doing here. So what we have to do here is we have to tell it what types we want our methods to return. And we do it with a kind of interesting syntax. We do less than symbol, and then we say, what are we passing into this method to conduct the search? We'll say an object of type plant. Okay. How do we want to update progress? We're not going to worry about progress, but integer is usually what we use for that. And then finally, when the doInBackground completes, what is it going to return to the onPostExecute method? And that is going to be a list of plant objects. So kind of an interesting syntax here, or we can make it an array list. Either way is fine. Kind of an interesting syntax we have here, but that's how we specify generic identifiers. Then we have an open curly, and we press enter, and we get a closed curly for free. Okay, so this is our async task. This is how we're going to handle our thread. We have to tell it what data we're passing into the thread, which will be a plant object, what units we're using to measure progress, and what the thread will return when it's finished. I hit save or Control S, either way. I see that async task has a red curly, so I'm going to click on that because we know anytime red underline. Anytime we have a red underline, the first thing we want to do is fix it. So we mouse over and we see async task can't be resolved to type. That's an easy fix. Control-Shift-O will fix that. Okay, now we still have a red squiggly, but this time it's on plant search task. And take a look at this. Plant search task must implement the inherited abstract method AsyncTask doInBackground. So the quick fix, add unimplemented methods, or just Control-1. And we'll see something very interesting here. Look at the method that was created, a method called doInBackground. Do you remember that? We just saw that method when we were looking at the AsyncTask documentation. But remember, doInBackground leaves the result and the incoming parameter to be defined by the user using a generic. Okay, so take a look. What is the incoming parameter? A plant. Mouse over the plant, and what is it? com.plantplaces.dto.plant. You can tell by the package name, this is a class that we have made for our program. This is not an Android class that was developed as part of the Android API. Instead, it's a class that we have made for our program. Okay? And now we see that it also returns an array list of plants. Again, that matches up exactly with the generic identifiers that we set above. So generic identifiers can allow us to extend a class, or in other words, subclass a class, and we leave the method parameter type and return type to be determined by the subclass, which is what we've done up here. I know that sounds a little bit goofy, but it's a lot better than the alternative, which is a lot of crazy casting. This is a lot safer because it's checking our types at compile time, not at runtime. We're less likely to get one of those nasty class cast exceptions like we saw in an earlier video. Okay, so let me add some JavaDoc to this. I'm going to say this, we'll say the steps in this method will run in a separate non-UI thread. Or actually, probably easier if I put that in parentheses. A separate non-UI thread. Okay, now let's remember that we have another method. Okay, I'm going to say, remember that method onPostExecute? And because we're actually overriding a method from AsyncTask, we know we can do a little shortcut here. I can type onPO, just type about 4 letters, hold Control and hit space, and Eclipse will figure out what I want to do is override the method onPostExecute. And again, look what's very interesting here. Notice that the parameter type coming into this method is the same as the return type from the doInBackground method. Okay, and why is that? Because when doInBackground is finished, automatically onPostExecute will be invoked on the UI thread, and it's going to get past whatever results came from doInBackground. So let me put some JavaDoc so we don't forget what that means. Okay, this method will be called when doInBackground completes. The parameter result is populated from the return values of doInBackground. This method runs on the UI thread and can update UI components, and therefore can update UI components. And we save. And we save. Okay, so what do we want to do here? Okay, we've done a pretty good job so far. I'm going to do a little bit of cleanup and save. But what do we want to do here? Let's look at our onCreate method. Okay, and let's think to ourselves, what if this is simulating what we will find on the network? Probably this part right here. Okay, probably a lot of this right here. This is simulating what we'll find on the network. So I'm going to Control X, which will cut. Oh, a little bit slow. And I'm going to paste this in our doInBackground method and paste. Okay? And then I'll simply say return all plants. Now, one trick is that it actually is receiving a string, not a plant object. Yeah, I could change that if I want. Doesn't really matter. Why don't we go ahead and change it? I'm going to change that generic type. We're going to change it to a string, which means now I change this to a string as well to match. Okay, there we go. And now we need to take that string. That string currently has a variable name arg0. So we'll say search terms. What's interesting is you also see that string has 3 dots, which means we could pass in as many strings as we want. They'll be stored in an array. It's a little bit tricky, but here's how we handle it if we're only getting one string. We're only getting one string, so let's access that one string. String search term equals search terms 0. Okay, we're just pulling off the first string that's passed in. Okay? And now everything compiles. Okay, and we save. Now we're going to need to pass in that string, aren't we? We're going to need to pass in the search term, which is this right here. That's easy to do. Okay, we'll do that in just a moment. Okay, what we need to do is create an instance of our plant search task that will run in a separate thread. Okay, we just create an object like we'd create any other object. Plant search task, which is the class type here. PST equals new plant search task. Okay, execute the plant search task thread. Okay, and we save. Okay, pst.execute, and then we pass in search term. Okay, so this will actually start a new thread. I'll put some comments to that effect. This will start a new thread and invoke doInBackground in that new thread. Okay, it will pass the search term into that new thread. Okay, that works. So what we've done here on our onCreate is we've retrieved the name, the search term that the user has typed in. We've created a new object of our plant search task, and we're passing the search term into that plant search task. That search term is going to arrive in the doInBackground method, and we're going to use that search term to determine what we're going to populate in an array list or a collection of plants, and then we're going to return those plants. But this will happen in a separate thread. Okay, this logic will happen in a separate thread. So I'll put a breakpoint there so we can watch it, and then I save. Just a few more things to go. The next thing we need is the UI-specific logic, which is where we take the results of that plant search and we actually show it in the UI in a list. And these are these last few lines here that I'm going to Control X. I'm going to copy those out, and I'm going to paste those in onPostExecute. And there we go. Okay, so we'll say show the results in the list. show the plant results in the list. Show the search results in the list. Actually, I'll tell you, let me move that comment down below. Okay. Adapt the search results returned from doInBackground so that they can be presented on the user interface. Okay, just a couple more tweaks. First of all, this is expecting a collection called all plants, but the name of the variable coming in is called result. We just need to make those one and the same, all plants, like so. Okay, and save. And okay. One other thing that's a little bit tricky, because we're in an inner class, this first argument no longer matches. This first argument no longer works. We have to do something tricky to point to the outer class or the enclosing class, and the enclosing class is plant results activity. So we have to say plant results activity dot this. As soon as we do that, we're in good shape. I'll go ahead and set a breakpoint here. Okay, we have a breakpoint there. I'm going to set a breakpoint in our onCreate. I'm going to save. And believe it or not, at this point, we've done enough refactoring to put the creation of our plant results in a separate thread. Now, right now, it's just dummy data. But after I've committed this to GitHub, after you viewed this video, in a separate video, we will explore how we can actually make this a network call and invoke it over the network. So I'm going to save. I'm going to Control M. We know we have several breakpoints set, and we're going to take a look at how this runs in the debugger. So I right-click, Debug As, Android Application. Might take just a moment to come up, so I'll pause the video for a moment, and we'll watch it all unroll in the debugger. We'll watch the different threads execute simultaneously. Okay, and naturally with the magic of video now, I have the emulator up and running. I'm going to go ahead and type in Redbud, and I'm going to hit search. And what we'll see is that we're going to go from the search screen to the results screen, and we're going to start to see our threads running. Now, one thing that's interesting, if you followed along from about 4 videos ago, I showed the liveplantplaces.com mobile app. What's interesting is that what we're looking at here is the Plant Places app we're working on as part of this class. But if you see up above, I still have the Plant Places mobile app running and all the threads going. So using Eclipse, we can actually debug 2 different processes, 2 different apps, and all of their threads at the same time on one emulator, which is pretty handy if you're operating from one app to another. It makes life pretty interesting. Okay. So I've clicked search, and let's watch very carefully what's happening. First of all, let's see how many threads we have currently running in our app. We have, looks like we have thread number 1, which is our UI thread, 9, 10, 11, 12, 13, 14, 15, 16. So just doing some rough math there, looks like about 7 or 8 threads we have going. We'll remember those numbers because when we do hit our plant search task, we're going to get a brand new thread running. Okay, so I choose F6 on Create. Oh, I'm sorry, I have to get my thread in focus. Because we can debug through multiple threads, the one you want to debug, you have to expand and click to select like so. Then the buttons above will light up and you know it's been selected. So on Create, what's our search term? It should be Redbud. There's our Redbud. Now what we're doing is we're creating a new object of type plant search task. And then we're going to say execute. Now, as soon as I say execute, we're going to get one more thread in this stack here, which is going to be our thread that's going to go fetch our plant results. Hard-coded right now, but I'm going to click execute, and let's take a look. Sure enough, take a look. Here's thread number 11, which is now running in doInBackground, and as I click on that, what we're going to see is that this background thread is going to run. Now before I do that, notice that the UI is still locked up because I haven't told my UI thread it's safe to go. I'm going to go ahead and do that. I'm going to resume the UI thread, and what we'll see is that my user interface will come back in just a moment and be responsive, and there we go. We have a UI. It doesn't have any results on it yet, but we do have a UI. And I could very well, whoops, 1 second. Sorry, I've lost my video screen there. There we go. Okay, you probably didn't notice that, but I lost my video frame there. Okay. So the UI is responsive. We could put a cancel button on here now and tell it to cancel any running process. We could do that if we want, because the act of actually searching for plants is now running in the background on a separate thread, thread number 11. Okay, so there's thread number 11. And we see this is the same logic we had before. We're going to get the search term, which is still redbud. We're going to create an array list, which will be our result type. If the search term is redbud, okay, we're going to populate a redbud plant and add it to our collection of plants. And then we're going to return. Now, as soon as I return, this thread number 11 is going to shut down, and we're going to get a breakpoint again in thread number 1, our UI thread. So I mouse up. You see through thread number 1, there's nothing by it to expand. It's currently happy and running. But as soon as I finish up this doInBackground method that I'm in right now, in my thread number 11, thread number 1 is going to light up again. And thread number 1 is going to light up in the onPostExecute method. Because remember, onPostExecute is going to run in the UI thread, and it's going to capture whatever results were returned from the doInBackground method. Okay, so I'm going to go ahead and play. We'll see thread number 11 is going to go dormant. Okay, I'm going to click. I'm going to tell it to play. Thread 11 will go dormant. Thread 1 will light up. Okay, there's thread 1. Thread 11 is now dormant. Okay, and thread 1 has picked up. And here's thread 1 on onPostExecute. Now we still have a responsive UI, but without results. What we're about to see is that because we're running back on the UI thread, the setList adapter call is going to take the information that we gathered in the doInBackground method and put that onto our list, which will be visible in our UI. So I play, and I play one more time, and we can go ahead and just tell this to run. And the next thing we see, sure enough, there's our results. So that's how we can use AsyncTask to very easily create a threaded process that will run on a separate thread, allow the UI to be responsive, but then be able to update the UI once the thread has completed. So the important things we need to know that we need to create an inner class that extends AsyncTask. We know we need to pass in the parameter type that we're going to receive in the doInBackground, any kind of status update, which we haven't done yet, and then a collection or whatever results doInBackground is going to return. We know doInBackground itself will run in a separate thread, and we know when it finishes, onPostExecute will run in the UI thread, so we can access any UI elements that we want there. We cannot directly access UI elements in doInBackground because it runs on a separate thread. Okay, we know to start this whole process, we simply need to create an object out of our inner class. Okay, assign it to a variable, and then invoke execute. Execute will go through the overhead of creating this additional thread and then invoking doInBackground on that thread. So some great quiz question suggestions. I realize this is a little bit complicated material, but some great quiz question suggestions to think of from this. In our next video, we will explore